exclusion stuff, as well as mention the more general inclusion-exclusion formulas. So let's start with some really interesting information about art. And by that I mean my personal, well-curated collection of art films consists of 10 action movies, 5 Bruce Willis movies, and 6 crazy movies. Of course, there's some overlap between these sets, but all of the movies are listed here. They all belong to at least one of these categories. Obviously, it wouldn't be an art film if it didn't have either action, Bruce Willis, or craziness. So some facts about this. 3 of the action movies, action flicks, have our boy Bruce. Now 2 of the action movies, films, are crazy. 3 of the Bruce Willis movies are crazy. Crazy not being a pejorative, but crazy meaning a lot of zaniness. So, some more things that you should know, and obviously anyone watching this video already knows, but every Bruce Willis movie is either action-packed or crazy. And in my personal collection, I want you to notice that 2 of my crazy movies are low action or not action movies and don't have Bruce Willis. Those would probably be Tommy Boy and Billy Madison. No, Happy Gilmore, not Billy Madison. I don't know. I don't even own these movies. This is all predicated on lies. Okay, so question. How many of my movies have all 3 qualities? Well, I need to come up with some very clever way to represent all 3 of these sets. Maybe if I could come up with some letters. Oh, I know. How about A for action, B for Bruce, and C for crazy? There we go, that'll help. So something else that might help would be to draw for visual organization, to draw a Venn diagram of A, B, and C. And just a hint for drawing Venn diagrams in general. When I draw a Venn diagram, so I draw my first circle, whatever it is, I try to start my next circle from somewhere near the middle of the first circle. All right, I really want a lot of overlap, and then again, I want a lot of overlap with the next one. So I just want to keep track of A, B, and C here. Okay, now if I was really on top of things, I'd make a big Venn diagram and try to fill numbers in as I figured things out, but and you can do that. There's enough information here, but all we want to know is how many of my movies have all 3 qualities. So the question really translates to what is the size of A intersect B intersect C, right? That's what we want to know. All right, well, let's start by translating what we know. So we've got the size of A is 10, the size of B is 5, And the size of C is 6. Oops. What else? 3 of the action movies have Bruce. So the size of A intersect B equals 3. What else? 2 of the action films are crazy. The size of A intersect C equals 2. And what else? 3 of the Bruce movies are crazy. The size of B intersect C equals 3. All right, we've got a little bit more information. So as I get more information written here, I might pull it out of. I might pull the story out of frame. Okay, so we have that every Bruce Willis movie is either action-packed or crazy. So this one, and the next factor are a little bit more complicated. So every Bruce Willis movie, so we're looking in B here, every Bruce Willis movie is either in the action circle or in the crazy circle, which is saying that if we're considering things in this circle, all of them also happen to be in one of these 2 regions. So that means basically this region is empty. So that is to say the size of, well, how do I want to say this? I want to say the size of, the size of B set minus A union B, A union C is equal to 0. Okay, so that's worth knowing. Next, 2 of my crazy movies are low action and don't have Bruce Willis. So after filling this one in, think about what is this sentence saying? So we're saying 2 of the 6 films here are not in action and are not in Bruce. That's the same as saying there are 2 in this little region here. So that's what we're saying is C set minus A union B is 2. All right. Now, I've given you too much information to answer this question, or I guess I should say more than enough information to answer just that question. But with all of this information, you should be able to fill in precisely how many elements are in each constituent set. I'll give you just a second or two here so you can pause the video and try to work this out on your own. And then I'll go through it at least the way that I have done it. Probably not the only way to do it, but I'll go through it the way that I have done it. Okay, so something that I want to mention here is what I've called corollary 1 in my notes. And corollary 1 is basically that if I take the union of 2 disjoint sets, then the union is the size of the union is the size of the sum. So A intersect B is disjoint implies that the size of A union B is equal to the size of A plus the size of B. And this holds because if I know that A intersect B is disjoint, that means I know the size of A intersect B is 0. And if we go back to this, here if I know A intersect B is disjoint, that means this is 0. So I have A union B equals, size of A union B is the size of A plus the size of B. Okay, so we're going to be using this fact, and even pulling it out separately and calling it a corollary is maybe not so necessary, but I'm going to be using this fact as we move forward. So how do I use this fact? Well, what I want to do is I want to get a handle on some sets that I can use to do inclusion, exclusion, and get the size of this triple intersection. In particular, just on the Venn diagram here, I'm going to show you, I want to get a handle on A intersect C and on B intersect C. This isn't the only way to do it, but this is a way that works. In fact, I think it's slightly easier if you instead go with A intersect B and B intersect C. And I'll let you work that one out on your own. So let me do it a slightly more complicated way. So the slightly more complicated way, but again, not to be overly complicated, but just because if you find a way that works, go for it, right? Slightly more complicated way, I want to say, well, if I have that the size of C is equal to 6, and it's also equal to the size of C minus A union B plus the size of C intersect A union B, then by knowing this and by knowing this, I know this. So I know the size of C is 6. I know the size of C minus A union B is 2. So 6 equals 2 plus what? Plus 4. Okay, so this tells me the size of C intersect A union B equals 4. Also, there's a reason I'm doing it this slightly more complicated way. And C intersect A union B is going to be this sort of cartoon mustache shape here. So what are the constituent parts of the cartoon mustache shape? Well, I've got A intersect C, and I've got B intersect C. But what do you know? I've got a handle on both of those. So I'm going to define E to be the set A intersect C, and I'll define F to be the set B intersect C. Now, we notice that if I take E intersect F, I'm going to get A intersect B intersect C. And I also notice that if I take E union F, I'll get precisely this set. This is C intersect A union B. So that means that I can apply inclusion-exclusion to these sets. So the size of E union F is equal to the size of E plus the size of F minus the size of E intersect F. All right, so now I can go back in and find, well, what's the size of E union F? The size of E union F is the size of C intersect A union B. So that's 4. The size of E is the size of A intersect C. A intersect C is 2. And the size of F is the size of B intersect C. B intersect C is up here, it's 3. So 4 equals 2 plus 3 minus the thing that I wanted. Ding, 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 ding. So this tells us that the size of A intersect B intersect C, which is of course the size of E intersect F, equals 1, and we are done. And in case you were wondering, that one movie that I own that is action, crazy, and stars Bruce Willis is of course Hudson Hawk. Because what other movie would it be?